Hi, everyone. Welcome. Today's session is on managing your research data. So me and my colleague Sue are going to be talking about this topic today. So we'll start by just introducing ourselves. I'm Ruby. I'm a health sciences librarian, so I work in the health sciences library on campus.
I'm Sue. I'm a science librarian. The office should technically be there, but I'm actually at WCVM currently.
And before we get started, we'll just mention that we're going to try and monitor the chat, or Jordan's going to be monitoring the chat as we go through everything today. If you have any questions online, you can type your questions in the chat as we go through everything today. And then if you have any questions in person, you can just raise your hand. And then we'll also have some time for questions at the end as well. And then we'll just start by acknowledging that the University of Saskatchewan is located on Treaty 6 territory, the traditional lands of the Cree, Saulteaux, Nakota, Lakota, and Dakota peoples, and the homeland of the Métis. So these are the learning objectives for our time together. So we'll become familiar with research data management, or RDM, and the research lifecycle. Understand reasons to manage your research data well. Understand what's involved in research data management and where you can begin, and know where you can go for help and where you can learn more. Okay, so first, just to kind of warm us up a bit, we wanted to get a little bit of a sense of people's initial understanding of research data management. So just in the chat or in person, you can just shout it out. What comes to mind for you when you think of research data management or managing your research data?
Data lifecycle.
That's a good one. Yeah, no, go ahead.
Managing your citations.
Totally. I don't know if anything's coming through online or if anyone else has any ideas.
We've got having a safe, protected place to store your data.
Totally. That's important.
And online annotated bibliography.
Okay, yeah. Yeah, oftentimes too, we'll get answers like spreadsheets or code books. We'll talk a little bit about those as well. But yeah, thank you for just shouting those out. And then before we go further into talking about research data management, we like to show this little short video. It's 4 minutes long and just kind of demonstrates why research data management is important. So I'll try and navigate to that video. Oh.
Working.
I just want to make sure it's on this screen too. Okay. Oh. There we go. And then get full screen.
Hello, my name is Dr. Judy Bunan. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Bunan.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in the box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Recording in progress. Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No, I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosim.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you could buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah, yes. SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is and SAM3 and SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay. Now, let's see if I can get back to the slides. Okay, next. So, yeah, that's an old video, but it's still really relevant today and just kind of shows some of the difficulties that researchers can be faced with when they're, trying to save or use other people's research data. And there are many issues raised in the video that relate to research management, and we're going to be talking about some of those issues today and what you can do to mitigate those issues. So first, it's important to understand what research data means when we're talking about research data management. So research data is any information that you collect, generate, or use to validate your research findings. And research data serve as like the basis for your arguments and conclusions in a publication, report, any sort of like final outcome of your project. And research data are highly context and discipline specific, so they can be and look like different things in different situations and in different disciplines. So these are some examples.
I think the folks online are having trouble seeing slides since the video played.
Okay, let's figure that out.
Let's just stop the share for a second. Start again. See. Oh yeah, it says
Good to go?
Sorry.
Yeah, no worries. Thanks for fixing that. Okay, so yeah, some examples of research data. Let me just see here. Okay, there we go. So we can think about it in terms of like quantitative versus qualitative data. So when we're thinking about quantitative data or numerical data, that could be things like geographic coordinates, patient vital signs, environmental measurements, signal recordings from a program or a tool. Those could all be examples of quantitative data. Specific examples of this could be the number of smokers per province or the pH level in a soil sample. And then if we're thinking about qualitative data, that could be things like audio recordings, free text survey responses, oral histories, papers and documents. Those would all be examples of research data. And specific examples of that could be interview recordings, video or audio, and then written stories from community members. We can also think about research data in terms of primary and secondary data. So primary data would be data that's collected firsthand or original data. So examples of this would be maybe you're tracking migratory bird patterns. The data that you collect through that would be primary research data. Another example could be the clinical trial data on the efficacy and safety of a specific drug. And then secondary data is data that has been collected by someone else. It might have already been analyzed and distributed, but it can be used and reused for new research projects. So examples of this could be census data collected by Statistics Canada, or a data set that another researcher has used in a different project. Okay, so with all of those different types of research data in mind, when we're talking about research data management or RDM, we're talking about the planning, maintenance, and documentation of all aspects of your research data throughout a study or a research project. So RDM refers to the practices and policies that are involved in the collection, storage, access, use, and sharing of research data. And the ultimate goal of RDM is research transparency. So that means that throughout your project, from the beginning, initial planning and designing stages, all the way to the end when you're writing your final paper, everything in the process is clear and transparent surrounding how your data was collected, processed, stored, analyzed, and preserved. And that means that it's clear to you, also clear to your research team, and then thinking as well about any potential users of that data or collaborators potentially, making sure that it's clear to those kinds of people as well. Active and best practices in RDM can help you organize and keep track of your data, use and understand your data, and preserve your data and share your data when that's appropriate. So when it comes to data management from a communication perspective, historically, the publication has served as the only mechanism from which we can understand the data that's underlying the methodology and the research. So this kind of means that we're only seeing the tip of the iceberg in terms of what goes into the data management process. So good data management is trying to bring all of those additional materials that you create, those processes that you take, the programs that you use, and make those more visible and accessible to help ensure more research transparency. So research data management is very much tied to this idea of the research lifecycle, which Sue's going to talk about a little bit more later. And the research lifecycle is sort of a framework to help think and talk about the different processes that are involved in research. And there's often going to be, feedback loops within this process. And you might see different steps in other sort of frameworks of the research lifecycle, but this kind of idea just helps us sum up what we're talking about when we're thinking about research data management throughout the entire research lifecycle. So really, generally speaking, the research lifecycle consists of hypothesizing and planning your research, designing your study and your research, collecting the data, analyzing the data, and then publishing and sharing your findings. Okay, so what does good research data management look like? Again, Sue's going to talk about the specifics of this later, but kind of generally speaking, good data management can look like having an inventory of your research data and an organized file structure for that data. It means being thoughtful and deliberate, having a strategy for describing and documenting the research data that's being collected and described. It means you have a plan for storing your data, backing up your data and preserving your data. And then when it's appropriate, it means that you have a plan and a method for sharing your data as well. So kind of beyond that iceberg example from a few slides back, and before we get into the specifics of RDM, we'll talk about why it's important to do research data management and why it's important. So one reason that it's important is because research data loses value over time. So this study featured on the slide here looked at a number of publications over a number of years and tried to access the data. And then you can see in the bottom right image there, the sort of long tail of decline that as a publication aged, the research data lost value. And this can be due in part to poor research data management because people stop caring for the data, the proper documentation isn't there, and it's maybe saved in formats that people can no longer use, or people don't remember where it exists. There's sort of lots of reasons why that tail is there. Another reason that RDM is important and why you should pay attention to it is because it's now a requirement for tri-agency funding. So in recent years, the tri-agency, which is the Canadian government's research funding agencies, they've developed this RDM policy. And the policy states that anyone wanting to apply for tri-agency funding must support research excellence and make good use of public funds or taxpayer money and support that research by following research data management best practices. In addition to making data more understandable and more usable, practicing good RDM is also a responsibility to the individuals and communities that we might be working with in our research. So historically, data collected from marginalized populations has been misused for nefarious reasons without the consent of those populations. So another goal of RDM is to ensure that you as a researcher and a research team are thinking about and taking the necessary steps to ensure that that data is protected and that it's governed according to the principles and practices of the populations that you might be working with. Another reason RDM is important is journal and publishing requirements. More and more often, academic journals require that you share and publish your research data if you are going to publish with them. So just as an example here, PLOS journals have a data sharing policy or a data availability policy that indicates that authors who publish with them are required to make their research data publicly available. Of course, there are variations to this if, for example, you're dealing with sensitive data, but overall, this is their policy and it's required to publish with them. Another reason to care and to pay attention to research data management is because it benefits the larger research ecosystem. These are just some examples here, or instances of open science and open data being talked about in relation to COVID-19, and kind of on a large scale, thinking about building larger data sharing systems, especially within the context of a pandemic, and the importance of open data and open science, and the impact that can have on health research development, and even potentially health outcomes. Okay, so this is an example here showing how managing your data well can be equivalent to writing a good recipe. So on the slide, we have this recipe for heavenly pie. This is a real recipe that my colleague found. And we can see on the screen a list of ingredients and some instructions at the bottom there. Does anyone see what might be wrong, or what hurdles you might run into if you were to try and make this recipe yourself?
Two ripe bananas. How ripe is ripe?
Great question.
What granulated sugar is how granulated do you want the granulated sugar?
Totally. Yeah.
Put what in shell?
Yeah.
Shell.
Put in shell, yeah.
Or you put the egg into the eggshell into the pot. Or
Yeah.
something. Makes sense.
My first question is what shell?
Where did it come from? Yeah, and I'm like, do you mix all these ingredients together? Do you cook it at all? What do you do with each ingredient? It's not really clear. So just kind of relating this to RDM, if these were instructions on how you did your research, how you came up with your final project, it would be really unclear to someone else how you came to your final product. What steps did you take to get to your final product is not clear at all. So if you think of the published article, your final product as the pie, and then you think of the methods and the data of your research as the recipe for the pie, we can see that the methods and the data in the case of this heavenly pie are really unclear. And just to kind of illustrate that another way, this is what someone's research data might look like. And this alone, this spreadsheet data is basically useless to someone who is just looking at this data. You know, what do these variables mean? What does P1, P2, P3 mean? Maybe you could guess some things. Maybe these are participant numbers, but you know, you're not sure. And then even if you knew that, what are all of these numbers? Yeah, what are these variables representing? Ideally, a researcher could have data that looks like this, but along with this, there would be a data dictionary or code book explaining what each of these things mean. So someone could look at it and understand what's going on and what the data represents. So kind of tying this back to the heavenly pie recipe example, being clear and explicit in your research data documentation about what things mean, how things are done, and making sure that everything is understandable is important when we're thinking about doing good research that is clear and transparent and therefore reproducible, which supports, you know, as I touched on earlier, a better, more transparent research ecosystem. Okay, pass things over to Sue.
Sounds good. Before we move on, is there anyone with any questions by any chance? Everyone's doing okay? Awesome. And there's nothing in the chat.
No
Okay.
questions on the chat.
Great. I'll try this clicker to see if it works. If not, then I will continue on the slides. So we're going to talk a little bit, Ruby had mentioned it a little bit before, about how does data management actually come into play as you're doing your research, and how is it tied to the research cycle that you might be using. So let's go a little bit back into it. So at the end of the day, RDM is not something that we do at the end or just at the beginning and that's it, but it's something that is the most effective and efficient if we're able to kind of have it all throughout the life cycle. So it's really important to kind of start thinking about it as you're formulating research ideas or your question, and then taking it all the way to see in each step what kind of research data you would be collecting, as Ruby had mentioned about like different types of research data. So just wanted to ask you all, what type of research are you doing, and about where in the research cycle do you think you are at? I'll go back into the research cycle. Would anyone be... Is everyone at the starting stage? Yeah.
Pretty much at the starting stage.
Awesome.
I mean, I'm a first year, and so really just kind of learning how to use the interface and understand what the data means, but.
For sure. Would
Yeah, I'm doing computer science, and I'm probably about halfway through the study design and the methodology phase.
Awesome.
So like I'm finishing up the software that I want to use, and then I'll probably end up designing the evaluation methods.
Okay, awesome. So still probably at like the first two stages. Is what about everyone else? Is everyone else kind of in that like first two stages mostly? Which is great, because that's like the best timing to start. So this is really great that everyone's here at that timing. Is it similar in the chat as well? Awesome. Okay. Yeah, no, thank you for sharing like which stage you're at and a little bit about your research. That's very exciting. So when we look at kind of like the beginning stages of the research data lifecycle, we're going to be at the stage where we're developing research and we're actually looking through defining the hypothesis or your research question. You might be thinking about, where do I want to publish? What kind of research am I actually doing? Which direction I'm going in? So I'm glad to hear that some of you are in this stage, because this is like a perfect stage. But then after that, once we have that a little bit more formalized, that's when I think usually we get into the method development stage, as you shared about your research. So this is like the part where you could start considering about that data management plan. And it's becoming, as Ruby had mentioned before as well, it's becoming increasingly important that you do have that, especially if you're on a research project that has tri-agency funding. They're really requiring that to be a part of your research. And even if it's not, it's something that is actually quite useful to have. And of course, if you're thinking about also publishing things, your data management plan could also be kind of put in repositories and to be shown as well. So it's a good way to also show a little bit of that research output as well. So this is a good place to kind of think about your overall research. And once we get a little bit more into what the data management plan looks like, you'll also see that it actually is going to be very helpful for your research, because it kind of goes through and lists like what kind of data are you collecting, what kind of research are you collecting, and all the questions are actually quite relevant to what your research will look like, and it actually helps to kind of set that direction and define your research a little bit more in that terms of data. So it's actually, it goes very hand in hand. So it's not something very separate that you're doing on the side. And then we're going to get into that study design. And then of course the data collection stage. This is probably something that's probably most would be obvious to many people, where you would be collecting a lot of different data, and then that's what you would be also recording. Like, how did you collect the data is also part of that data management as well. Surprisingly, that part might not be as obvious, because sometimes like how you collect the data, as we saw in the video, like what kind of software you use, if you use software, those could also be would need to be recorded as well, because that might be important in accessing your data. You might be thinking about how do you store your data throughout your research, because for some of your research, you might be collecting like a lot of data, like big data as well. So thinking about that storage and where you have that, and if you're working in a team, how are you like managing that data across the team? So that's also going to be pretty big. And also thinking about that raw data and analyzing the data. And once we get to that data analysis, then we'll be also looking at documenting the findings, like what kind of analysis, what kind of results are you generating? And then you're also, if you're, again, going back to that software idea, like if you're using a software, thinking about which versions are you using, because sometimes how you generate and how you render your data will really depend on which like version that you're using as well. So thinking about that. And then finally thinking about publishing. At that publishing stage, then you're thinking about finalizing what kind of data will actually be shared in a repository. So again, going back to that idea of if you're thinking of publishing your articles, then your data, a lot of like what publishers are saying nowadays is that your data needs to be available in a repository. So kind of thinking about that part, like which repository are we going to use? Unfortunately, currently our institution itself doesn't have like a separate data repository that we have, but we do have something called the Harvest. If some of you have heard about it, that is our own repository where you can put your theses, dissertations, and they sometimes could post up some types of data if needed, but there's also some other ones that we'll talk about as well. So this is kind of like the full picture of like what that data management will look like throughout your research life cycle.
Dee talked yesterday in our open science and open research presentation about lots of different tools for sharing data and methods and things openly and things like that. So that recording is up on our YouTube channel now. So if you want to have a look at that one, there's lots of different tools that she suggested in there that are sort of open source places that you can share that data and share those things and sort of get that stuff out there.
No, that's a really great mention as well. And thinking about that, it's kind of like everything goes hand in hand with that open science, that open knowledge, or open, our openness to having these data available really is beneficial for the whole academia, but also for our public, right? Because a lot of like our research, at the end of the day, it does come from that public funding. And then for us to be also responsible in returning that kind of that, trust that we have received to be saying like, oh, this is the data, this is the result, this is what we have, and being open and transparent is we're recognizing more and more of that importance, I think. So it's really, that's a really good point. So kind of we're going to go a little bit more into then, like we talked a little bit about like, okay, that's what kind of happens in the life cycle. Then how do we get started? So has anyone started in data management planning yet, or any of the creating a plan yet? No, that's totally fine. That's totally cool. I'm glad that everyone's here to kind of think about that. So let's start with like kind of like the basics, and some of them we're bringing back like the basic principles that you might already know, but putting it into research. So firstly, I think the biggest thing is to think about what data are you collecting. So thinking about like creating that, starting to list that data inventory. So what types of data are you collecting? So kind of like, maybe I'll throw this question as kind of like a, maybe like think about your research and potential research. What type of data do you think you'll be collecting? Would anyone be okay with sharing that?
I mean, I'm not really collecting data,
Mhm.
but like you organizing data with SuperDarm, which is like a over the horizon radar that studies the ionosphere. And I'm just looking at like previous like geomagnetic storms and see what happens in the atmosphere and stuff like that. So I guess I'm not really like collecting data, I'm more just like using their interface to create like bad plots and products, understand what's happening, so. It's not really collecting data, but
Yeah, no, that's a really good point. Sometimes we would be not like the ones actually going in and creating the data, but at the same time, that's a really good point. When you're using that data points, and that also becomes your, like, not necessarily, it's not your data, but that might be also important to have that recorded somewhere, right? Because in case like they decide to change the interface or they decide not to keep it recorded. So it might be nice for you to also have that stored in some way or form as well. So that could be part of data. So that's a really good example, I think. Yeah.
I'll be collecting and generating a whole host of data types, from videos to images to database files that contain camera positions and like 3D space, to 3D reconstructions of scenes, to variations of processes done to those and transformations done to each of those scenes. And so it's the opposite, everything.
Right.
Different kinds.
Yeah, no, lots of different kinds, which means that it's going to be like very important for you to think about, where am I going to be storing this? Because it sounds like there might be quite a big files, and you might need quite a bit of spacing as well. So that might become important. Anyone else? If not, I can.
Cassidy Online says they'll be collecting qualitative data through interviews, and Molly also qualitative data, but through surveys to start.
Awesome. So I think like we mentioned that a little bit later too, but like especially when you're thinking about doing interviews and surveys as well, it's quite important. This is again like something that might be obvious, but for some others like might not be, is that we need to also think about collecting the questions and making sure that that's part of the data as well. So like how you collected the data, like so your survey that you've sent out, like the interview questions you had, that also all becomes data as well. So if you're doing interviews and if you're transcribing, the transcribing thing also becomes data, like the raw data before you do the analysis. So yeah, all of these are really great examples and variety. So thanks for sharing them. So thinking about like kind of like we talked a little bit about this. What are the file types that are generated? Like, are you collecting one file type, multiple file types? If you're doing videos, are you doing only one type of video? Are you doing multiple? Can it be played easily throughout different devices? How stable is the data in its original form? Like, will it change versions? Like, for example, if you're using web data, then will the website be archived, or would you need to be the one actually actively archiving it? How much data will you be generating? Thinking about like how much space that you'll need, and then what other information is necessary to understand the data. Like going back to that data library, will you need that? Like if you're using spreadsheet with a bunch of different things, will you need that? Protocols, templates, like what kind of things would you need so that like anyone who's coming to see your data is kind of like, okay, I kind of like, they might not understand specifics, but they should still be able to understand what this data is presenting. So after you kind of think about like, oh, what kind of data am I collecting? The next part that we like to think about is now thinking about writing the data management plan. Honestly, step 1 and 2 kind of goes together, because step 2 will prompt you to think about step 1. So it's not really like a separate step, but these are like the different components of a DMP. So we have responsibility and resources. So who is responsible for doing if you're working in a team, like who's going to do which part like of the data management. It's really important to be very specific in how you do things, because as I think like there's previous experiences where you kind of like link it together, like, oh, we'll generally do this, everyone in the team does this. It usually doesn't work. So thinking about the responsibilities, like what kind of resources are available to you, like talking to your supervisors to see like, are there any storage options that your supervisors have already, or is there like different things that the team is already working with? Thinking about the ethical and legal considerations. So something like the qualitative data that you're collecting, are there going to be any like confidential, sensitive data that you'll need to be protecting? Thinking about how like the data collection and data documentation, as you see, like a lot of these components are going back to that life cycle, data storage. Like, how are you going to be preserving your data? So that's a little bit different from storage and preservation, like thinking about like, okay, I've stored the data somewhere, but how am I actually going to keep it for there, like for a period of time, as long as you need it, and how is it going to survive after? So I know sometimes it happens where we lose the data, for example, because like some things have been saved in OneDrive instead of SharePoint. So thinking about that preservation as well, that like long-term, like stable spot. And then finally thinking about the data sharing as well. So just to touch a little bit more on the data sharing, because it's becoming a little bit more important, yet it's something that requires a little bit more consideration. So thinking about like what data can you share and will you share? I think thinking about that is going to be also very important as well. So starting to think about that early and preparing that, especially if you have sensitive data, is going to be very important because you'll need to receive consent. You'll need to think about like how you're going to be coding the data as well if you're using sensitive data in order for it to be in a shareable format. And especially if you're working with specific populations like vulnerable populations or indigenous population, you need to also think about like, you need to also get that consent and discuss with the community on what that will look like. So you would need to think about that. So what are some like important, like when we talk about why share, this kind of goes back into that open science idea back again, but a lot of the times you'll get a lot of credit for sharing. It'll also improve collaboration with the research community. It'll improve the data standards because that's what we're, I think, continually hoping to improve. And then you'll gain access to new data and research, not only for yourself, but for others. But when you need data as well, then it'll be really helpful. If everyone is in that like sharing mode, then we can also gain that data and we can limit multiple like duplication of work sometimes as well by having these access to different data that everyone has worked with. So you might be analyzing different things, but you might be working from the same data set. So it's really helpful in that way. So these are a couple, Didi might have mentioned a couple of these, but these are some of like the big ones that we talk about. So one that we mention quite often is FRDR, so Canada's Federated Research Data Repository. That one's free to use currently for someone who is affiliated with the university in Canada, and you could put your data in this repository, and they can also put an embargo until like a certain period if you put data in there and you need it to be embargoed. So it's a really good place to kind of consider, like if you need a place to put your data in. But one thing to note, it's a pretty general repository. So if you're looking for other repository options, you can go into R3 data. And you can go into your specific discipline and they'll kind of show you a list of places where you can store your data in. One thing to note about like when you look for databases in there is that sometimes those databases or those repositories won't be free to use. So some of them will need to be paid. So that's why we often say like FRDR is probably a really good option because it's free and it's Canadian and it's like currently like one of like the easier places to actually for you to send data and for it to be stored in. So just again, like thing to note is public data sharing is always not possible. We love the idea of sharing, we love the idea of openness, but sometimes it's not going to be possible. So you need to think about like if you were working with specific population, if you didn't receive consent, communities like that you collect data from are the ones who should be deciding on where the data goes. Private company also, if you're working with them, they might restrict certain types of sharing. It might be protected in certain ways. So if you want to share your data, you need to kind of think about those things and see, like, think about different ways. So include in the opt-in, like the having like the consent process, having discussions with the communities early, And then considering ways to anonymize the data. So what I've seen some teams do, for example, if you have like specific data, then what they do is that they have like they have coded data, and then they have like a separate dictionary of what that coded data means. But then what they do is that they don't share that publicly, but then publicly. So that's kind of like one way of thinking about and considering. So it's a little bit hard to see. It's really small in font, but this is what like a data management plan might look like. So as you see, it's not like something, it sounds like it's something that's so grand and big and it's something complicated, but when you look at it picture, like it can be really simple as in like bullet points, something that you just write down like a couple lines about saying like, oh, this is how I'm collecting, this is what I'm doing. So it's feels a little bit daunting at first, but when you actually go into it, then it might not be as like scary as it looks. So kind of like in getting started, this is like probably like a really good place to start. Has been created in collaboration, especially by our RDM librarian. He's on sabbatical currently, but he's coming back in July. So if you have any RDM related questions, please feel free to direct them to us, but just also note that he'll also be coming back really soon, which is really exciting. So he actually created this guide. Just one thing to note is that it goes through different sections and different components, but not all the questions that he asked or like this guide asked will pertain to you. So it's just like a general guide supposed to like cover multiple throughout all the disciplines. So just if you're feeling like, well, my research doesn't cover this, do I need to answer? The answer is like you just kind of like go along and see which one really is related. So kind of like thinking about that. There's another one that is really useful. This one's like a really called the DMP Assistant. It is created by the Digital Research Alliance of Canada and University of Alberta. This is actually also a really great tool because what it'll do is that it kind of prompts you and it gives you all the questions, kind of like the guide, but like it kind of creates a guide alongside with you, and it gives a couple examples depending on which subject area you come from. So that's also a really good tool for you to get started on and then start typing in and getting prompted as well. So these are really great tools to get started on creating that DMP plan. So to move into kind of thinking about like, okay, then where are we like thinking about the file structure and the storage plan? So kind of going back to the really basics, it seems really obvious, but sometimes like it's actually surprisingly one of those things that are not followed, and that's what causes a confusion. We had an example that I've heard where someone kind of misnamed the file at one point and they had a mix between raw data and the analyzed data, and you can imagine how badly that would have went. And sometimes like what would happen is if you do the wrong dates in a wrong format, then it'll all mix up like the dates of actual data, and that could be really detrimental depending on your research topic. So it's really important that to think about like having one directory per project. So having just like one folder per project, so you're not mixing different projects. Keeping raw and processed data separate, so not having it in the same folder. Creating a README file. So what a README file is that it kind of sits in each of those folders and it explains how to save data. So it's kind of like helpful, especially if you're in a collaborative format where you're working with different team members. It explains to each team member saying like, okay, this is how we're saving the data. So it explains like, for example, like we're saving the data in year, month, date format, or like month, date, year format, so that everyone's kind of consistently following through with like the same way. So that's also really helpful, and also for you to go back and to remember what format you had followed. And then another thing is like making files human and machine readable. So usually across different, I've noticed that when I also use a Mac and a PC, I noticed that sometimes like something that I type in as a file name works in one device versus the other. So keeping it to letters, numbers, and underscores will ensure that it's like transferable between different devices. Be descriptive as much as possible, but not going overload so that you can't really read it. So having like the project name, like what does it actually contain, and then the dates would be really great. Important to keep it consistent, and finally like keeping it like sequential ordering, so listing it as 001. And so the reason why it's really nice to name it 001 is because sometimes like in some formats, if you name it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sometimes the 11 is said to be like almost categorized with one, depending on which like device you use. So that's why it's like sometimes nice to keep that 1001 format. Kind of like going back to that README file. So it kind of like describes what the data is in that folder, methods of data collection. So it can include like how data was collected, when and where the data was collected, information about related data. So if you're using a software, then it explains about like, oh, these are the software that were used or needs to be used to read the data. And finally, like how the data set should be used and analyzed. So it's kind of like a little description of like what the data in the folder would look like. This is one example of what a file organization would look like. As you see, we have like different, this is for one single project. So in that one single project, you might have like a data folder. So this is just an example and it might look different for different projects, but as you see, they separate the raw data and the analyzed data just so that you have both formats in case you need to go back. You kind of also have like the admin stuff. So any like notes or meeting notes that you've had. There's also protocols if you decided to create protocols or templates as well. So going back to that interview, like any questionnaires or experiments that you did. And finally, if you're at the writing stage, you also might have like a separate folder for like all the writing and all the backups and all the different versions as well. So as well as all the data and figures that you create. So it's kind of like just like one way of showing like, oh, this is like one thing that you could follow. Another like kind of like final thing to think about is storing your data. Where does your data live during your project at different stages? So like a collection, it might be living in different parts depending on which phase you're at. And what does like the data, if it lives in different places throughout like the different cycle, then how does that transformation look like? Like, will you need to use a USB? Will you need to save it? Or will you need to use different devices to do so? This is just like one thing that I would like to mention, just like this, depending on what type of data you have, like whether it be sensitive, restricted, then there's like a different recommended or different places that the universities say like this is the best place and this is probably not a place to do. As you see, one of the places that is like the best for you to score is called Data Store. It is unfortunately not available readily to students, but if you discuss with your supervisors should be able to, like faculty members should have access to Data Store. So kind of like exploring to see and discussing with your supervisors to see if there's a data store that you guys could get access to might be like a good place, because Data Store actually they get quite a bit of space for them to work with. If not, SharePoint is also like a place where they really caution you, but it is a place that is used quite a bit as well. So kind of going into our final stage is implementing a strategy for building documentation of each stages of your data. So also like kind of like this, it sounds like it's going to take a lot of work, but at the end of the day, in the long term, it's going to save you time, because as you record more and do this, like it's going to be helpful, and not only in like, it's going to be helpful in your manuscript writing because you're recording what you're doing in each stage. So it seems like it's a lot of work in the current stage, but once it becomes a little bit more operationalized, then it'll help at the end. So defining data. So when you're documenting data, it's really important to think about you're defining your data so that others understand what you're talking about. So I saw that a lot of you were laughing as you're watching the video, because we see what had happened in that video where he had basically like almost like a spreadsheet, but then he himself didn't even remember what each of the sections meant, which means that the data in it really is useless at that point, because we don't even know what that data really means. So it's really important that not only that others understand, like by helping others understand, it helps you understand as well in the years when you go by, when the years go by, and especially if like different people will be working with your data at later times. So that's why it's going to be very important for you to list your variables if you have any variables, and to provide definitions of what they mean. Like we had that SAM1 or SAM2, SAM3, you're just kind of like, okay, what does that actually mean? And at the end, we didn't really understand what that meant at the end as well. So kind of like ensuring that you yourself know what that variable means, like, and especially if you're using specific measurements, then what type of measurements, what kind of meters are you using? How are these variables represented, like text, scale, number, And then finally, what are the units of measures? So kind of like going back to what I had mentioned. So this is why it's really important to also consider creating like a data dictionary that kind of like explains and guides your data. So talking about like, okay, I have this spreadsheet. This is what this section means. Like if you're using any abbreviations, if you're using any specific different ways of labeling data, then it's going to be really important for these data dictionary to be existing so that later on you could be like, okay, when you're asked a question and you're not recalling it, you can either refer them to the data library or it could come with it so that like people can easily understand your data. So like kind of going back to like all these like different things, like the data dictionary could be kind of a solution to providing that. So these are kind of like all the step-by-step like things that you could do to get started. So kind of to summarize what was talked about, like it's really great that everyone's in kind of like the beginning stage because really planning the RDM is most effective when you start from the beginning. Using a DMP to guide your data collection, analysis, storage, and preservation processes is going to be super helpful in doing so. DMP is basically a communication tool, like where you're discussing with like not only your team or not only your supervisors, but also discussing like, oh, this is how what I did with the data and explaining to the research community and academia and how you had collected the data as well. Just know that research is fluid, things might change. That means that your DMP will change, but that's something that's really natural. So just because you began with something doesn't mean that you'll have to kind of like do it to the end. It kind of goes along with your research. Like if it changes, then your DMP may change. So you don't need to feel like this is the only way that you need to continuously follow if you had it in the beginning. And then just think about the future you. It's all of these are really going to be helpful for you in the future. So thinking about that is important. These are just a couple resources for getting started. I believe the slides will be posted, so you'll have like links to it. Like it lists like a couple different like guides or different lessons as well. Contact your librarian. You all have librarians on your subject areas. You should be able to find your librarian by searching your subject area there. And then, or feel free to contact one of us as well. We're very happy to help, or we're happy to like direct and work with your librarian as well. There's other supports on campus, just thinking about like research and computing. There's also Chaser. That's like a really great place to think about getting some research support as well. Finally, want to acknowledge Kevin. He's the one really that created the slide deck. We had modified a little bit of it, but then he's really like has done a lot of work in RDM. It's exciting that he's coming back in July. So as you're going more into your research, and if you're noticing that your timelines July and August, he would be also a really great resource to talk to because he has abundant knowledge in different disciplines. So he would be a really great resource as well. Thanks for listening. I know that was a lot of information, but any questions from anyone?
Yeah.
Say your data has multiple stages of processing, so then you have raw, like first layer processing, second layer processing, third layer processing, etc. You mentioned keeping the raw and process separate. Would you essentially then treat each of those categories as its own and keep those separate, or would you have one process folder with like bundles of?
I think it's at the end of the day, like what you find to be the easiest, like depends on how many of like the raw formats there are, how many of the like the process formats there are. I would say like keeping it separate is probably going to be the easiest at the end for like from my understanding. But if you're noticing that, you know, like you only have one file in one folder, then at the end of the day, that might not be also helpful, right? Like you're going into that separate folder. So it would really depend on how it's easy for you and how you kind of explain that like process.
Yeah, I was gonna say the exact same thing. I think just hearing about it, it seems like it would make sense to have each of those different stages be in a different folder or something. But at the end of the day, if that workflow didn't make sense for your team and you're like, this is ridiculous what you're doing, you don't have to do it that way. But as long as it was clear what you were doing,
Documentation.
Exactly. Yeah.
Yeah, I think it would matter whether or not you needed to be able to go back to different stages. At any point, right? So if I'm on stage 3 and all of a sudden I'm like, actually, I need to look at that stage 1 again. because of something, just to be able to quickly access that and know that that was stage one and that that is definitely separate from what happened in stage two. You know what I mean? So if it's things like that where you know you're gonna need to be back and forth, then definitely separate.
Totally.
Yeah, but
Yeah, good question.
any other questions either here or online? Nothing on the chat yet. I know Kevin talked about the simplicity of those README files last year. That's something really stuck with me. And just using those README files, not just using README files as just a really simple way to explain this is the data in this folder, this is how we collect it, this is what we're doing with it, this is what it represents. These are, you know, maybe that is the data dictionary is part of that. But those README files within that folder of data just seemed like such an awesomely simple way to keep track of that and to like just that file always goes with that data. And for other people to access it as well. And I know something Kevin mentioned last time even was everything should be as simple as it can be that way, right? Like don't create new systems or new whatever for things where a README file would do the job just as well. Because 5 years from now, a text-based README file will be readable by by everyone. Whereas, oh, I saved it in this kind of database with this kind of, encryption, whatever, it might not be readable, right? So just keeping your data organization as simple as possible and you like as basic tools as possible is future proofing it as well. So yeah, it was just something that stuck in my head from last year.
Yeah, great advice. Yeah.
That's a really great point. At the end of the day, you're the one who will be needing to do the also like managing your data. And more complicated you make it, there's less likely that you're going to also follow through with it, right? So making sure to keep it simple enough, but like effective, of course, but like simple enough for you yourself to follow is also going to be helpful for future you, especially when you're kind of like heading that time crunch, right? So thinking about like what is going to be feasible with me and what's going to work with me that makes sense to others is going to be also really important to think about.
Well, I think we're at 11, so I think that's kind of our time, and I'll respect everybody's time. But I want to thank Sue and Ruby so much for coming out today, and I will definitely share the slides, and the video will go up on our YouTube as well. So those will be shared back to anybody who registered. So thanks, everybody.
Cool. Thank you.
Thank you.